A computer can be designed in a so basic way that it don't need special any register at all other than some basic registers like accumulator. Okay, we do that so that we can keep the cost of CPU as minimal as possible. The simplest type of organization can have is single accumulator organization. Let's see about single accumulator organization. In single accumulator organization, there will have a arithmetic and logic unit. And what will this arithmetic and logic unit do is that it will perform some operation like addition and then store the result. And for storing the result, most of the computer have general purpose register called accumulator. So there will have a accumulator. It will arithmetic logic unit will store the result in the accumulator. It is called accumulator as it is supposed to accumulate the result, and this results is accumulator can also given as input to the ALU. The result of this accumulator can also give as the input to the ALU, and there will be a database to which the memory will be connected. This is the memory which will be connected, and arithmetic logic unit will also be connected to this. This is the simplest type of architecture where we don't have lot of registers. We have only few registers. The special purpose special register that is present here is accumulator, or maybe there can be some register like program counter. This program counter, this program counter will say what is the next instruction that has to be fetched from the memory. And other register that could be present is instruction register. This instruction register will get the instruction from the memory and will save it here. An instruction register will interpret the instruction and generate the control signal. This type of organization is called single accumulator organization, because here there is only a special type of register present which is accumulator. In the single accumulator organization, we only use one address instruction, or zero address instruction. So if we see a zero address instruction, it will be like increment accumulator. Increment accumulator is a zero address instruction. Zero address instruction. It means increment the accumulator by 1. This instruction means increment the accumulator by 1. Yeah, it is a zero address instruction. Then the example of a one address instruction could be add y. So that means that add y with the value present in the accumulator and stored into the accumulator. Okay. So it means add accumulator, put the value accumulator, add the value present in the memory at x, and add with memory at y, not x, memory at y. Get the value at memory at y and add with the accumulator value, and then store the value in the accumulator. This is a one address instruction. So in single accumulator instruction, there could be zero address instruction or one address instruction. Now we are going to talk about general register organization. In general register organization, there will have a ALU, and along with that there will have lot of general purpose register, like those registers R1, R2, R3 and R4. Now as we have lot of register, we can use lot of register in one instruction. Like for the instruction could be add R1, R2, R3. The meaning of this could be like maybe put add R2, R3 into R1, add R2, R3 and store it into R1, or we can say it's like add R2, R1 and R2, R2 and store it into the R3 register. We can say both of that. So the advantage of general register organization is that the number of instruction that could be required for write a program is going to be very less. So this is going to be the advantage of using general register organization. But what are the disadvantages of this general register organization is, here we need lot of registers first, and the size of the instruction is very big, so the instruction register should also very big. And when you are fetching the instruction, then your bus size is also going to be very big. So the general register organization will with the CPU will be very costly, and but the advantage will be like it will be very fast because we have lot of register. Most of the general purpose computer follow this organization. That means most of the general purpose computer have many register in there. In general register organization, we could have three address instruction or two address instruction. Like this is the example of three address instruction. This is a three address instruction, and in two address instruction what we can do is that we can write this instruction like this: add R1 and R2. What we are going to do is that instead of using R3, we put the value of addition into the R1, like add R1 plus R2 and store the value into R1. So here we are using less number of registers. So this is a two address instruction. Two address instruction. So in general register organization, we could have three address instruction and two address instruction. Now let's see about a stack organization. In a stack organization, we could have a zero address instruction. The stack we have seen in the data structure is going to see, we are going to use the same stack here. We build the stack in either in the memory or in the register. Both of that possible. We can think a set of register as a stack, like there is lot of register we have, like R1, R2, R3, R4, R5, R6, like this: R1, R2, R3, R4, R5, and we can think all those register as a single stack, and we can have a pointer which is going to point to the top of the stack. It is same like the in the stack in the data structure. To perform addition using a stack organization, what we will do is that first we will push first operand x, and then we will push second operand y. And for addition we are not going to use any other operand. We are just going to add this x and y and store it in the top of the stack. So the top will contain x plus y. Okay, so instruction will be like this: push x, push y, and add. And this add instruction, what we will do is it will add those x and y and store the value of x and x plus y into the top of the stack. Here we can see that add is a zero address instruction. This is a zero address instruction, and push and pop are one address instruction. Both of them are one address instruction. And push and pop, what push and this to push is a one address instruction, and pop is also a one address instruction. And those instruction is used to put the operand into the stack or outside the stack. Push used to put the operand into the stack, and pop used to take the operand from the stack and store into the memory. So from here we can understand that depending on the number of instruction present in number of operand present in the instruction, the size of the instruction varies. Like in three address instruction, the size of the instruction is bigger than two address, and two address is bigger than one address instruction, and one address is bigger than zero address instruction. To understand the operand, we need to understand modes, because if there is a operand present, and to understand this operand is a constant value or a memory address, we need to know the mode of that. That is why the mode is needed. So now we are going to learn about all the types of mode to know the operand and what this operand is going to do.